Hi folks, we're in Mod 3, Novice Problems Solutions. We're going to look at problem number 8. This is a problem on hypothesis testing, and hypothesis testing has traditionally given people some difficulty, so let's look at this very carefully. The first thing in a hypothesis test that you have to determine is what kind of a test you're going to be performing. In this particular case, in problem 8, we're going to perform a one-sample hypothesis test. And so in a one-sample hypothesis test, you are taking a single sample that you derive someplace, you do a survey, and you're going to compare it to a standard. That standard for us is the standard from the Intercollegiate Ultimate Mixed Martial Arts Confederation. They provide a number. They say this is what the standard is. So we're going to compare William and Mary to the standard. The proposition here is that William and Mary is in this division called the PBS, the Puny But Smart Division, and they're not real happy about it, and they're wondering whether they really need to belong there. So we take data from 45 William and Mary competitors. This is the group of William and Mary that we have, 45 competitors, both men and women. And we're going to compare the average that we find there to the average of the standard. The first thing we're going to do is create a hypothesis test. In this case, it's almost invariably the case in a single sample hypothesis test that H sub 0, the null hypothesis, which by the way is the kind of well, I just don't know, I'm not going to make a commitment one way or another until I know better. So we're taking kind of the neutral position. No, there is no difference between the intercollegiate group and William and Mary. The alternative then can be one of two things. We can either say, well, wait a minute, we found that the number for William and Mary was less than for the international group or the intercollegiate group, so I'm assuming that William and Mary is in fact puny but smart. Or we can say, hey, I just don't know. In this particular alternative, we're saying I don't know what the situation is, and I can't make a decision based on the data that I've got, but I know that it's different. So how do we attack this problem? Well, one way to attack the problem is to use Minitab. We can also use Excel. I will tell you, the Excel calculations are a bit more basic and require more analysis. The Minitab calculations, because it has a built-in capability, are pretty direct. The data analysis tool for Excel does not include a one-sample test. So let's begin with the Minitab solution. We can copy the data that we have. The data that we have that's important here is, by the way, I've broken this up into two different areas. The very same data, but I've sorted by men and women over here on the right because I'm going to use that later. But here is the original data. We have 45 data points for men and women on our team, and I can copy those. I want to copy those. I'm going to go now to Minitab, and I'm going to place the data here. This is W and M. And then I'm going to go to stats, basic stats. I'm going to go get one sample test. You don't want the Z. The Z assumes that you know that this is normally distributed data and that you know the population standard deviation. We're not given that here. The intercollegiate group, the Confederation, did not give us that information. So we're going to use a one sample t-test. It says, all right, what do you want to use? Well, I want to use let me get rid of this because we put in other data. I had it there before. I want to use C7 because that's our data. And I want to perform a hypothesis test. There's a tiny little check mark that you have to put there. And I have hypothesized that the mean, because the null hypothesis is that there's no difference, that the hypothesized mean is 163.8. Then I hit OK, and I receive information here that says, okay, here's the information. And this is, you can see this is for a two-tailed test. A two-tailed test, again, says, I don't know. It's different. I don't know whether it's higher or smaller. So the p-value is what we concentrate on here. We look at this p-value and we compare it to our alpha. If this p-value is smaller than alpha, then I reject the null hypothesis, because this is a probability number. What is a probability that, in fact, William and Mary is just like everybody else, and that I could get this particular value? Well, it's a tiny little value. So my assumption is it can't happen, or it happens so rarely that I have to believe that William and Mary is in fact different, significantly different. That's why we reserve that word. So if you go back to our sheet, here's the results. I have done the analysis for both a one-tailed test and a two-tailed test. The first one was a one-tail. The two-tailed test is available by choosing a different alternative. You can go to Stats, Basic Stats, one-tail t-test, and Options. And in the options, we can choose a different test that our mean is in fact less than the hypothesized mean. Hit OK here, and here's our data. And now we see that in fact our p is even smaller because we've actually chosen a direction in which the size occurs. Now let's go and do this test now with Excel. In Excel, and by the way, you can find this done in the book starting on page 209. I need to gather some data. Here's the data that I need. First of all, I need the hypothesized mean for the Confederation, our mean, and this is a calculation that I've done over here, where I've calculated the average for our population, or sample, P3 through P47. I need the alpha, 0.05. I need the sample size, 44. And I also need the sample standard deviation. Notice what this calculation is. A sample standard deviation I've taken here for all of this data for the 45 competitors is this STDEV.S for the data. .S for sample. Okay, now let me go back to our data. The first thing I do is I calculate a test statistic. And the test statistic is what comes from our sample. I take the sample value 153.6, I subtract that from 163.8, and that is in the numerator. In the denominator, I want to calculate the standard error, and the standard error is D55, which is the sample standard deviation that we calculated, and I divide that by the square root of the number of sample size, and that's 45. Again, what this denominator is our standard error for the problem, and the standard error is divided into that difference. Okay, now if we calculate this value, we get negative 0.281. It's negative. Why? Well, because our value 153 is smaller than 163.8. And I've got a graph over here that says I'm going to establish a fence between two critical values, 1.68 we'll see in just a second, and 2.02. And if my sample value falls inside that critical value, I cannot reject the null hypothesis. If it falls outside, I will reject the null hypothesis. And by the way, in both these cases, the sample, the test statistic does fall outside the region, so I will reject in both cases. How do I calculate these values? This is done in the book. The t.inverse function needs the probability, which is, in our case, 0.05, and it needs something called degrees of freedom. Degrees of freedom is our sample size, 45 minus 1. No other way to explain that, but you just have to know that the degrees of freedom are 1 minus the sample size. And I do that here. For the one-tailed test, it's T dot inverse. For the two-tailed test, it is T dot inverse dot 2T for two-tail. And then the inputs are the same, 0.05, and the values of the degrees of freedom. I get those values, set up this fence, and I see if my value 2.8 falls inside this region or is more extreme than the region either on this side of the fence or on the other side of the fence. And that's when I reject, when that value is more extreme. All right, that's the end of our problem 8.